Section 3.3, to solve systems of inequalities. Let's take a look at our first example. Use a table to solve each system. Assume that replacement values for the variables are whole numbers. So we want to solve each one of these inequalities or equations, graph them, and determine what the solution set is for the system of equations. Let's take a look at the first equation. X plus y equals 2. Recall when we make a table to solve and graph equations, we have to solve for y. So I'm going to subtract x on both sides. That gives me a negative x plus 2. Now we generate a table, x and y. I'm going to determine my values for x that I'm going to substitute. I'm going to choose 0. When I substitute in, negative 0 plus 2 gives me 2. I'm going to choose 1. A negative 1 plus 2 is 1. And a negative 1. A negative times a negative is a positive 1 plus 2 is 3. Let's do the same thing for our inequality. 2x plus y is less than 5. Here, solving for y, I'll subtract 2x on both sides. That gives me a negative 2x plus 5. Now we need to create a table. X, y. I'll select 0 as my first choice. Negative 2 times 0 is 0 plus 5 is 5. I will select 1. 1 times a negative 2 is a negative 2 plus 5 is 3. And 2. 2 times a negative 2 is a negative 4 plus 5 is 1. Let's graph the equation. That's going to give me 0, 1, 2, 1, 1, and negative 1, 3. Now I graph my line. And for my inequality, I use my table, 0, 5, 1, 2, 3, 4, 5, 1, 3, 1, 2, 3, and 2, 1. Now, since this is an inequality, I have to determine whether it's a solid line or a dashed line. Since my first one is an equation, it's an equality, it's a solid line. That is the solution to that equation. The inequality is going to use a solid line if it's less than and equal to or greater than and equal to. It's going to be dashed if it's just greater than or less than. Here, since it has an equality, it's going to be a solid line. So I will connect the points. Also recall that I need to shade on one side of the line. So when I do that, I need to select a point on either side of this inequality. Remember, this is the line that represents 2x plus y is less than or equal to 5. This is my equation. So I need to select a point on one side of that line and determine whether it's true or false. If it's true on that side, I shade on that side. If it's false on that side, then I shade on the opposite side. So I'm going to select 0, 0 because it's the easiest. When I substitute in 0, 0, 2 times 0 is 0, plus 0. 0 is less than or equal to 5. That is a true statement. Therefore, I am going to shade on that side of the line where 0, 0 came from. That is below the line. Now, the shaded area represents all solutions of the inequality. But what I want to do is I want to solve the system of equations. The solution for the systems of equations is only the points that intersect the shaded area and the equality of x plus y equals 2. And the ones that share are all of these points. The shading goes over all of those points. Therefore, the solution to this system is the red line. Let's take a look at our next example. Again, they want us to use a table to solve each system. Assume that the replacement values for the variables are whole numbers. So let's start with the equation. I'm going to add x to both sides to solve for y. That gives me y equals x plus 1. Let's generate a table. Choose my values. I'm going to choose 0, That gives me 1, 1. That's going to give me 2. And negative 1 is going to give me 0. Let's start on our inequality. Let's solve for y. I'm going to subtract x on both sides. That gives me 2. Y is less than or equal to a negative x plus 20. Let's divide by 2 on both sides. That gives me y is less than or equal to, and 2 has to go into both. That's going to give me a negative 1/2 x plus 10. Let's create a table. X and y. I'm going to select 0. That's going to give me 10. I'm also going to choose 2. That's going to give me 2 times a negative 1 is a negative 2 over 2, which is a negative 1 plus 10, which is 9. And I'm going to choose 4. 4 times 1 is a negative 4 over 2, which is a negative 2 plus 10, which is 8. Let's graph both of these. My equation first, 0, 1, 1, 2, and negative 1, 0. Since that's an equation, I definitely use a solid line. And my inequality, 0, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 2, 9, and 4, 1, 2, 3, 4, 8. Now, just determine whether that's a solid or a dashed line. Since this is a less than or equal to, it's going to be a solid line. Now I determine where to shade. And I select a point below or above the line. I'm going to select one below it. I'm going to select 0, 0. When I substitute in, I'm going to get 0 is less than or equal to 10. That is true. Therefore, I'm going to shade below the line. So I'm going to shade this way. This represents all solutions for the inequality. The line here represents all solutions for the equation. But to solve this system, I need to find where the shading and this line intersect. And it will intersect from this point down, representing all points below this point on the equation line. Here's our next example. They want us to solve the system of inequalities. Here I'm going to graph these a little bit quicker. I'm going to use the slope-intercept form. And again, I still need to solve for y. So let's start out with the first inequality. I'm going to subtract x on both sides. That gives me a negative 2. Y is less than a negative x plus 6. Now I'm going to divide both sides by a negative 2. That gives me y less than a negative 1 divided by a negative 2 is a positive 1/2 x, and a positive divided by a negative is a negative 3. Recall, this is slope-intercept form. M is the slope, so my slope is a positive 1/2. Means my line will rise from left to right. And here my y-intercept is 0, negative 3. I'm going to use that information to graph that line. 0, negative 3, 1, 2, 3. And I'm going to use the slope to plot the points. Since it's positive, I'm going to go up 1 to the right 2. Up 1 to the right 2. Up 1 to the right 2. Now, from the inequality, I know that I'm going to use a dashed line. And I also know I need to shade. And if I shade, we can go the old-fashioned way by selecting a point. I'm going to select 0, 0, which when I do, I'm going to get 0 is less than 0 times a half is 0. 0 minus 3 is a negative 3. And this is false. But I also could have used the symbol. So since this is false on this side, I know I shade on this side, but The symbol also tells me I need to shade on the side where y values are less than that line. So I didn't really need to select a point. I could have just used that information. So here are the solutions to that graphed inequality. Now I go back to the other inequality, and I'm going to do the same. I'm going to solve for y, which it already is. So y is less than or equal to a negative 3 over 2x plus 5. Using this formula again, my slope is a negative 3 over 2. So it's going to decrease from left to right, and my y-intercept is 0, 5. Graphing the intercept, 0, 1, 2, 3, 4, 5. Counting down because it's negative, 1, 2, 3, and to the right, 1, 2. Down, 1, 2, 3, to the right, 2. Down, 1, 2, 3, to the right, 2. Then I'm going to use the inequality symbol to determine whether it's dashed or solid. Since it's an inequality, it's going to be a solid line, so I connect the points. And then determine on what side to shade. If I just use the inequality, I need to select y values that are less than this line. Y values are below the line. Therefore, if I just shade on that side, the green shading represents the solution set for that specific inequality. The yellow shading represents the solution set just for that inequality. But what I want is the solution to this entire system. So where these intersect is the solution to that system. So that is in this checkerboarded area. So the system of equation solutions is this solid shaded area. Our next example, I have x is greater than a negative 3. Again, we're solving the system of equations. Remember, when I have one variable, I'm going to use that inequality and just set up a table, x and y. Negative 3 is the value that x represents. I know it doesn't equal a negative 3, but we're going to graph that line there and then determine whether it's solid or shaded. Y can be any value, 0, 1, 2. Let's graph negative 3, 0, negative 3, 1, and negative 3, 2. Then I determine whether it's dashed or solid. Here, by the inequality, I know it's dashed. And then, since x is greater, I want x values greater than that line. That would then be to the right of that line. This solves for that inequality. This shaded area represents that solution, but it does not include the line because it's dashed. Let's solve the other inequality. Y is less than or equal to a negative 2x plus 4. That's going to give me y equals mx plus b. Therefore, my slope is a negative 2, and I can put that over 1. That means my line will decrease from left to right, and my intercept is 0, 4. Let's graph. 0, 1, 2, 3, 4. My slope negative, so I'll go down 2 to the right, down 2 to the right, down 2 to the right 1. My inequality is a less than or equal to, so I know that's going to be a solid line. So I connect the points with a solid line. Then I determine the shading. I can select a point on either side of the red line, or I can just take a look at the inequality. I want y values that are less than that. Therefore, that would be below the line. So I'm going to take all my shaded area below that red line to represent the solution set for that inequality. But I want only the values that solve the system. And the values or region that solve the system are where the shadings intersect, and that would represent inside this area. So the solid shading represents where the solutions for this system exist. Let's solve the next system of inequalities. Here with the first one I have y is less than or equal to 3x minus 6. That's already in slope-intercept form. M is equal to 3 or 3 over 1. It's a positive slope, therefore my line will increase from left to right. And my intercept is 0, comma, negative 6. Let's graph. 0, 1, 2, 3, 4, 5, 6. And my slope is positive, so I'm going to go up 1, 2, 3 to the right 1, up 1, 2, 3 to the right 1. I take a look at the inequality. It is less than or equal to, therefore I know that it is a solid line. Now I need to determine where I will shade. Since y is less than, I want all values of y less than that line. That would be below the line, and this is going to represent all solutions to that first inequality. Let's graph the next inequality. I have y greater than a negative 4, x plus 2. My slope is going to be a negative 4, or 4 over 1. That's negative, so my line will decrease from left to right. My intercept is 0, comma, 2. 0, 1, 2. Slope being negative, I go down 1, 2, 3, 4 to the right 1. Down 1, 2, 3, 4 to the right 1. I take a look at the inequality. It's just greater than. So therefore my line will be dashed. Now I need to determine where I'm going to shade. I take a look at the inequality. It is just y values greater than that line. So I need to shade above the line. And the green shading represents all values that are solutions to that inequality. But for the solution set, I want where the shadings intersect. So therefore, that would be inside this area. The green solid shading represents all values that solve the system of inequalities.